All right, so today we're going to deep dive into a paper that honestly kind of like blew up the world of machine learning. It's called Attention is All You Need, and it really does live up to the hype.
It does.
So this paper, it's from 2017, and it introduced something called the transformer model.
Right.
And it's had this crazy ripple effect on how we use computers to understand language.
Like it's everywhere.
Yeah, like we're talking better translations,
Yeah.
chatbots that actually make some sense.
Much better chatbot.
All sorts of cool stuff.
Yeah,
So as you know, I love getting to the bottom of things.
of course.
So I was like, what is it about this transformer thing?
Right.
What is so special about it?
Yeah.
And it turns out it kind of boils down to this thing they call self-attention.
Yeah, it's all about attention.
Okay, so walk me through this.
So before the transformer came along, everyone was using these really complicated models called recurrent neural networks,
Yeah,
and they were slow and inefficient.
they were a pain.
And this paper basically said, well, what if we just focus on how words relate to each other?
Okay, so instead of looking at a sentence word by word,
Right.
like the model's trying to figure out how all the words connect to each other.
Exactly, like how they all fit together.
Okay.
Think about it. When you read a sentence, you don't just process each word one by one.
Right.
You're paying attention to the relationships between them,
Yeah.
figuring out, which ones are the subject, the verb, the object.
Right, how they relate to each other.
Exactly. And that's basically what this self-attention lets the model do.
Okay, that makes sense.
Yeah.
So how do they actually pull this off?
Right.
The paper mentions something called scale dot product attention.
Yes.
That sounds kind of intimidating.
It sounds a lot fancier than it is.
Okay, good.
So imagine you're reading the sentence, the cat sat on the mat.
Okay, classic.
Simple sentence.
So the model, using this scale dot product attention, calculates a score for how much each word should pay attention to every other word in the sentence.
So sat would have a high attention score with cat,
Right.
and on would connect strongly with both cat and mat.
Oh, that's cool.
Yeah.
So it's like the model is drawing lines between the words to show how they're related.
Exactly. Yeah, and that's what makes the transformers so powerful.
Okay.
Like you said, it can capture these relationships between words,
Yeah.
even if they're far apart in the sentence.
Right.
Remember those old models that struggled with long sentences?
Oh, yeah.
This one handles them with ease.
Okay, so the transformer is not afraid of a long sentence.
Mm.
Now, the paper also keeps mentioning this multi-head attention. What's
Yeah.
that all about?
So it's like having a team of experts analyzing the sentence,
Okay,
each one with their own specialty.
got it.
So one expert might be focusing on figuring out the subject,
Okay,
while another one's looking for the verb,
right.
and another one's mapping out the overall structure.
So instead of just one set of connections,
Right.
you've got multiple layers of analysis going on at the same time.
Exactly. And by combining all of those insights from the different heads,
Okay.
the model gets a much richer and more nuanced understanding of the sentence,
I see.
which is a big reason why the transformer is so good at things like translation
Okay.
and understanding like the subtleties of language.
That makes a lot of sense.
Yeah.
I'm starting to see why this paper was such a big deal.
Yeah.
But did it actually live up to the hype?
Oh, yeah.
Did the transformer perform better than those older models?
Absolutely.
Okay.
They tested it on a whole bunch of machine translation tasks,
Uh-huh.
and the results were incredible.
Wow.
It was not only more accurate, but it was also way faster to train.
So it's like speed and accuracy.
Exactly. Yeah, it's
Right.
like watching a clunky old car trying to race against a high-speed train.
Nice.
It was no contest.
Okay, so it's fast, it's
Yeah.
accurate,
Mm-hmm.
but they also claim that it's not just a one-trick pony.
No.
They say it can be applied to other tasks beyond translation, like
Yes.
this thing called parsing.
Right, so parsing is all about understanding the grammatical structure of a sentence.
Okay.
So kind of like we used to do in school, diagramming sentences.
Diagramming sentences, yeah.
Yeah,
I remember that.
and the transformer, with its ability to see how words relate to each other,
Yeah.
turned out to be really good at it,
Okay.
which was a big clue that it had learned something fundamental about how language works
Okay.
that could be applied to a whole bunch of different problems.
That's impressive.
Yeah.
You know, one of the things that really caught my eye in the paper was those visualizations of attention.
Oh, yeah.
You can actually see which words the model is focusing on.
You can.
And it's almost like looking into the brain of the machine.
It really is fascinating.
It is fascinating.
It gives us a glimpse into how it's thinking,
Yeah.
which is a huge step towards making AI more transparent
Right.
and understandable.
Yeah, like explainable AI, we hear about that all the time.
Exactly.
So you can actually see what it's thinking.
Yeah, for example, you can see how it figures out who a pronoun like he or she is referring to
Oh, wow.
by looking back at the previous words in the sentence.
That's amazing.
Yeah.
Okay, I'm also curious about this positional encoding thing.
Yeah.
So if the model isn't processing the words in order,
Right.
how does it know where they are in the sentence?
That's a great question.
Yeah, because order still matters, right?
It does. And so it uses these special positional encodings to give each word a unique tag
Okay.
based on its position in the sentence.
So it's almost like giving each word an address.
Exactly. Yeah. So
Yeah.
it knows exactly where it belongs,
Got it.
even if it's not processing them in order.
So it's getting information about the words themselves,
Yeah.
but also their location in the sentence,
Yeah.
and then using attention to figure out how those pieces fit together.
Exactly like solving a giant jigsaw puzzle,
I like that analogy.
where the pieces are words and the attention is figuring out how they all connect
Yeah.
to create that coherent picture.
This is really blowing my mind.
It's pretty amazing.
And I feel like we've only just scratched the surface here.
Yeah,
I'm already seeing how this paper has had such a huge impact on the field of AI.
for sure.
It's not just like a new model.
Right.
It's a whole new way of thinking about how machines can understand language
Absolutely.
and how they can process it.
Yeah, a whole new paradigm.
It really is.
Yeah.
And this is just the beginning.
Oh, yeah, we're just getting started.
So let's take a deeper look at how this transformer engine actually works when we come back.
Sounds good.
Stay tuned.
All right.
Okay, so let's crack open the hood of this thing and take a closer look
Yeah.
at how this transformer engine actually works.
Right.
I'm still trying to wrap my head around all the moving parts here.
It is a lot. It's like this finely tuned machine.
Yeah.
All these interconnected components working together.
Right.
But before we get too deep in the weeds,
Yeah.
just remember that big picture idea.
Okay.
The transformer is all about taking a sequence of data.
Like a sentence or a paragraph.
Right.
Even a whole document.
Yeah.
And figuring out how all those pieces relate to each other.
Right. It's like that jigsaw puzzle analogy
Yeah.
we used earlier.
Right.
But how does it actually go about, solving that puzzle?
Yeah.
The paper mentions these things called encoder and decoder stacks.
Yes.
What are those all about?
So think of it like an assembly line for language.
Okay.
The encoder's job is to take that input sequence,
Okay.
say like a sentence in English,
Right.
and break it down into this really detailed representation
Okay.
that captures all the meaning and the nuances.
So the encoder is like the note taker,
Yeah.
meticulously analyzing every little detail.
Exactly. What happens next?
That's where the decoder comes in.
Okay.
So it takes that rich, encoded representation of the sentence
Okay.
and uses it to generate something new.
Okay.
So that could be a translation into another language,
Okay.
a summary of the main points, or even a creative piece of writing.
So it's taking the essence of the sentence
Yeah.
as distilled by the encoder
Right.
and then using it to create something totally new.
Exactly.
That's pretty wild.
It is a powerful concept.
Yeah.
And what's fascinating is that both the encoder and the decoder
Okay.
are made up of these stacks of layers,
Okay.
kind of like floors in a building.
Got it.
And each layer uses those multi-head attention mechanisms we talked about earlier
Yeah.
to analyze the sentence from different perspectives.
So each layer is like a team of specialists.
Yes.
Focusing on different aspects.
Exactly.
And by stacking these layers, the model gets a more and more comprehensive understanding
Precisely.
of the text.
Yes. And remember, because the transformer can process information in parallel.
Right.
It can handle all these layers of analysis super efficiently,
Okay.
even for really long pieces of text.
That makes sense.
Yeah,
I'm starting to see how it all fits together.
good.
But the paper also mentions these things called residual connections and layer normalization.
Over in details.
They sound kind of technical, but I'm guessing they play an important role.
They do think of residual connections as shortcuts
Okay.
that allow information to flow more easily through the network.
Okay.
So it's like making sure that the signal doesn't get lost
Right.
as it travels through all those layers of analysis.
So each layer has access to the raw input,
Right.
but also the output from the previous layer.
Exactly.
Okay, what about layer normalization?
So that's like a balancing mechanism.
Okay.
It makes sure that the values within each layer are all on a similar scale,
Okay.
which helps stabilize the learning process.
So it's like making sure all the instruments in an orchestra are playing at a consistent volume.
Perfect analysis.
You can hear each part clearly.
Exactly.
Eh.
Yeah, it's amazing how much thought goes into designing these models.
Yeah, it's like every detail has been so carefully considered
It has.
to make them as efficient and effective as possible.
A real testament to the ingenuity of the researchers who developed it. It's like this blend of deep mathematical understanding
Right.
and clever engineering,
Yeah.
all aimed at pushing the boundaries of what's possible with AI.
It really is.
Yeah.
Now, remember the paper mentioned that the attention mechanism in the decoder
Yes.
is a bit different from the encoder.
It is.
Something about masking
Right.
to prevent it from, like, looking ahead.
Exactly.
What's that all about?
So that's this really clever trick to make sure that the model generates the output sequence in the correct order.
Okay.
Imagine you're translating a sentence word by word.
Right.
You don't want the model to cheat
Right.
by peeking at words that haven't been translated yet.
So it's like making sure it focuses on the task at hand, translating one word at a time,
Right.
without getting distracted by what comes next.
Exactly. This masking process forces the decoder to generate each word
Okay.
based only on the words that came before it,
Okay.
just like a human translator would do.
It's fascinating how they had to build in these constraints to guide the model's behavior.
They did.
It kind of reminds me of how we teach kids to read and write,
Interesting.
starting with simple words and sentences and then gradually introducing more complex concepts.
That's a great point. There are definitely parallels
Yeah.
between how we approach teaching humans and training machines.
Yeah, it's all about breaking down these complex tasks
Right.
into smaller, manageable steps.
Exactly.
And then providing the right guidance and feedback.
Exactly.
Okay, so we've got this intricate encoder-decoder structure
Yes.
with each stack made up of layers that use multi-head attention residual connections and layer normalization.
You got it.
And then there's this masking technique in the decoder to keep it on track.
To keep it honest.
Did I get all that right?
You did. You basically described the blueprint of the transformer.
Wow.
Of course, there are many more intricate details, but that's the overall architecture.
Okay, that's a lot, but it's starting to make sense.
Good.
And I can definitely see why this model has been so influential.
Oh, absolutely.
It's a real testament to the power of innovative thinking and careful engineering.
It really is.
It's like they sparked a revolution in the world of AI.
They did.
And it all stemmed from this simple yet powerful idea.
Yeah.
Attention is all you need.
It's like a rallying cry.
It is.
For a whole new way of thinking about machine learning.
Yeah.
Absolutely. By rethinking those fundamental building blocks of language models.
Right.
They unlocked a whole wave of innovation and progress.
And the ripple effects are still being felt today.
Oh, yeah.
This is all so fascinating.
It is.
I'm already seeing how this technology is changing the world around us.
Yeah, for sure.
But I'm curious to explore that real-world impact even further.
Me too.
So when we come back, we'll dive into how the transformer is being used in everything from Google Translate
Right.
to cutting-edge scientific research.
Yeah, wait.
All right, so we've covered like all this ground, you know.
Yeah, a lot.
From self-attention to encoders and decoders.
Right, all the building blocks.
Yeah, but how is this transformer thing actually showing up in our lives?
You're probably interacting with it more than you realize.
Really?
Yeah, think about those amazingly accurate subtitles you get on YouTube videos.
Oh, yeah.
Or like how your phone seems to magically predict the next word you're going to type.
That's true.
Those are both powered by transformer models.
Wow, so this isn't just some like abstract concept
Right.
living in research papers. The
Right.
transformer's actually out there,
Out in the wild.
making our lives easier.
Exactly. And it goes way beyond just convenience.
Oh, really?
Yeah, the transformer's being used for some pretty amazing things in healthcare, finance, and even scientific research.
Hold on, healthcare and science.
Yeah.
Tell me more about that.
So in healthcare, transformer models are being used to analyze medical records,
Okay.
predict patient outcomes,
Wow.
and even assist with drug discovery.
That's incredible.
Imagine a model that can sift through mountains of data to identify potential treatments for complex diseases.
It's amazing.
Yeah, that's the kind of power we're talking about.
What about in scientific research?
So scientists are using it to analyze those massive data sets
Okay.
in fields like genomics and astronomy.
Wow.
It can help researchers understand the structure of proteins,
Nope.
identify patterns in vast amounts of astronomical data,
Well,
and even accelerate the discovery of new materials.
it sounds like the transformer is becoming this all-purpose tool
It really is.
for tackling really complex problems.
It is incredibly versatile
Yeah.
because of its ability to process and understand vast amounts of sequential data.
Right.
And because it's so efficient, it can be applied to problems that were previously thought to be impossible.
So it's kind of like a Swiss Army knife for AI.
Exactly. A great analogy.
This is all so exciting, but I have to ask,
Yeah.
are there any downsides to this technology?
Right. It can't all be good.
Yeah.
You're right. There are always challenges with any new technology.
Right.
One of the big ones with AI is making sure that these models are developed and used responsibly.
That's a good point.
Yeah. We need to be aware of the potential impact.
Yeah.
And make sure that these systems are unbiased and beneficial to society as a whole.
So it's not just about building these powerful models, but using them ethically and thoughtfully.
Exactly. We need to have those conversations about the implications and how to create a future where these technologies are used for good.
It's like we're standing at the edge of this new frontier.
We are.
The possibilities seem endless, but we also need to proceed with caution.
Absolutely well said.
Yeah.
This paper, attention is all you need.
Right.
It was a real turning point in the history of AI.
Yeah, a testament to human ingenuity and the power of innovative thinking.
For sure.
And it's a story that's still being written.
It is.
I, for one, can't wait to see where this technology takes us next.
Me neither. It's a really exciting time to be alive.
It is.
And witnessing this technological revolution unfold.
Well, there you have it, folks.
That's it.
Another deep dive, complete. We hope you enjoyed exploring the fascinating world of the Transformer.
Yeah, it's amazing.
And the power of attention. Until next time, keep those brains engaged and never stop asking questions.
Always keep learning.